So let us study quadratic functions. Quadratic functions are functions that are defined by a polynomial of degree 2 or an expression looking like this. And here a is not equal to 0, otherwise it wouldn't be a quadratic function. So as an example, we take up this function 2x squared minus 4x plus 1. Okay, and first we are going to do this, that we are going to algebraically look at the properties of this function. And for a parabola, and this function is a parabola, you can graph it here. I already entered the expression for you, 2x squared minus 4x plus 1. If you look at a graph, this is a graph. So what we are going to do is that we are going to look at an algebraic method of determining the coordinates of this vertex, the x-intercepts, the y-intercepts, and equation of axis of symmetry and other things if they are needed. All right. So for the coordinates of this lowest point here, which is also called the vertex, you saw in the notes that if we use the technique of completing the square, then for this function, the vertex occurs at the point whose x coordinate is given by negative b over 2a. Okay, so this is negative b over 2a. All right, so for this function what we have, or for this example what we have this: a is 2, okay, b is negative 4, and c is 1. So we don't need c here at the moment, so we'll just use this negative b over 2a. Okay, so for the vertex we have x equals negative, and b here already is negative. Let's just write it there. Okay, divided by 2, and a is how much? A is 2. So what happens here is x is 1. So the vertex occurs at the point where the x coordinate is 1 and the y coordinate, that is, we can just substitute 1 in the equation here. Okay, and in the expression I meant, and here we go. So we got 1 is square, then times 1 here, and if you evaluate it, it will come out to be negative 1. So who is the vertex? The vertex is 1, negative 1. Okay, and then for the y intercept, what we have is, for the y-intercept, y-intercept occurs when x equals how much? When x equals 0. Okay, so in that case you have the y-intercept at f0. So here we go. This is 0 is square, so that will be a 0. And this is again x is 0. Let's just leave it like this. So, and then you have 1 here. So the y-intercept is 0, 1. Okay, so this is our y-intercept. Now for the x-intercept, what we have to do is we have to set y equals 0. That is, in this case we may say that the y-intercept occurs when the function fx becomes 0. So we just have to find those values of x. So how do we do that? Let's bring this equation in here and scroll up here. Okay, so here we are. So we'll set this equal to 0, and now we are going to use the quadratic formula. And remember, here if we go by those general notations, a is 2, b is 4, and c is how much? C is 1. Okay, and by quadratic formula, what you have, b equals x equals, so the solution equals negative b plus minus. Okay, so here we got plus minus square root of b square minus 4ac over 2a. Alright, so in this case, what do we get for the x coordinates there? We simply get negative of negative 4, okay, then negative 4 is squared, okay, then we have for a we got 2, for c we got a 1, and again for a here we have a 2. All right, so we have, so this will mean that we got x equals 4, and this is actually it's negative 4 square, and it doesn't matter when we are squaring it, but just to be, just to be like precise, okay, and 4 times 8 is 4 times 2 is how much? That's an 8, and here in the denominator we have a 4. So what this will give us is that this quantity is 16 minus 8. So this is 8, and the square root of 8 is how much? 2 is square root of 2. Okay, so we can write that down if we have to give the exact values. Okay, so this is 2 square of root of 2, and then we can write it as, sorry, I'm just over elaborating the basic notations. That's okay. So 2 square root of 2 over 4. So what does it give for the x-intercepts, or when you have y equals 0, x equals the values given by these. So one of them is 1 minus 1 over, or rather square root of 2 over 2. Okay, sorry, here square root of 2 over 2, and the other value is going to be x equals 1 plus square root of 2 over 2. All right, so if we write exact values of those coordinates of the x-intercepts, then one of the values is, this is one intercept, and then this is another intercept. Okay, 1 plus square root of, and we can verify our answers with graphing calculator. So these are the intercepts. Let's just go ahead and look into our calculator and see how we do about these many things. So I would do this. Let me try to enlarge it a little. Okay, all right, so here, okay, or we can do this. We know that we are not going too far on these sides, so for the windows we may just restrict the windows to the x coordinates to negative 5 to 5. We shall have a little better view of the graph. Oh, we had to adjust the y values as well. So for y we may go say negative 2, let's keep it at 5. Okay, so there we go. So we have this as our graph, right? And you can see that the y-intercept it as 0, 1, and here 1, negative 1 are the coordinates of the vertex, and here are the approximate values of these intercepts. Okay, all right, and you can get the intercepts by doing this. Like, just go to second calc, we are just verifying it, and this will be 0 of this quadratic. What it means is this, that the value of x that makes the function equal to 0. So we will look for the zeros of this. So first we are going to find this value. So it says we have to give a point on the left of this. Here is staying at 0, so we'll say okay, yeah, that part is fine. And then it asks us for a right bound, so we'll go slightly to the right. So this is the right bound, and for guess is going to start at a value for us to approach that intercept, And in this simple case, it will start at a good value generally. So what is the value of this 0? 0.29 289 approximately. Let's just go ahead and check it out. So that was, okay, so I will just see how much it is. It's like 0.29289 as we saw in this one, and same way you can compute this, or let's just do that since we already are in flow here. So now we will go ahead and look at this. We want a 0 again, so for the left bound we go close to that, so we gave it a value to the left of that. Then for right bound, yeah, we just have to enclose it in two values. Here we go, and then let's put this to work. It gives us 1.7071 as the other x-intercept. So here we are. We get these as, so yeah, this is the x-intercept as we saw in this one. Now later on in the other videos you will see that this is the lowest point and which you can actually determine, and the other videos will show you by using this minimum feature here. And you shall also see that if this coefficient here, if that is negative, then the parabola will be opening downwards instead of opening upwards as it is in this case. Okay.